Assalamu alaikum, everyone. Thank you for joining us today. Today, we are very honored to welcome Professor Muhammad Azzam in the last talk in the year of our series, Islamic Insights from Academics. Inshallah, he will be discovering an interesting relationship between physics and physics laws and natural phenomenon and something called the God equation. So please join me in welcoming Professor Azzam.
Thank you, everyone, for being here. Thank you, organizers, for inviting me and for all the arrangements. So first thing, to understand the context of the talk and have the expectation set for today's talk. God equation, understanding existence, so that's the first thing. And then through orbit, time and origin. So now origin has two different forms that I'm going to talk about today. One is the start of the universe and everything, the origin that we have, and then the origin that I'll talk about towards the end of the presentation. So keep in mind, visualize the origin that I'm going to talk about in the beginning and then at the end. Both of them have a correlation. So the idea behind origin is that there was an origin before, billions of years ago, and then there is something else today here relative to us, close to us. These two things, both are origins, but then they're correlated. So we'll try to find out the correlation. That's the first thing. So when you see origin at the end here instead of somewhere there, God equation origin, and then something else, for example, time, etc., orbit. The reason why it's here is because there was an origin and then there is an origin here. We need to find the correlation through this talk. God equation, what is this? Now, as a non-expert, I'm trying to present a universal equation of existence. That's one thing, harmony, in other words. And also, I'm trying to present the theory of everything. And we can call it God equation. The purpose of saying it God equation is twofold. One is trying to understand the one equation that if is true, anything else can be true. Something can be untrue as well, but anything else can be true. But if this equation is false, nothing can be true. So that's the idea. One holistic, universal equation of existence or harmony. And that's the idea. Once we have got this thing, we'll also understand the logic of God. So trying to understand the logic of the creator. So if you believe in creator, you can find the notion here through this God equation. If you do not, the other purpose of this talk is to bridge the gap between physics and philosophical inquiry. Philosophy, spirituality, these things. We mostly disintegrate these two things. We talk about science, and then we do not talk about correlated spirituality or philosophy. The reason being, science mostly talks about things based on evidence. And we think that anything that we have in spirituality or philosophy is mostly based on what? Based on beliefs, based on logic as well. Philosophy is based on logic. So that's fine. But then your logic could be your logic, may not make sense to someone else. That's the hiccup here. So what I've been doing in the past few years in the background as a non-expert, so I'm really slow in doing these things because I'm not a physicist. But I've seen that there's a really strong correlation between these two things, science and also philosophy. So that's the more explicit or primary purpose of today's talk. And in the background, I'm working on the physics-related God equation thing, more mathematical stuff. I'm not going to present those details here, but I'm going to give a notion or idea of the God equation. So now, do we have a set context for today's talk? I've been doing all these things on my own, completely 100%. I've never been in touch with any of these folks, but I believe that their publicly available content deserves acknowledgement. So I've put their names here. The idea of God equation was presented in a completely different context by Dr. Kaku. The concept that I'm going to present today is completely different from their concept, but the term was used before by them. And I think it's important to acknowledge them. And I've got key knowledge on concepts related to physics from Dr. Tyson, Dr. Cox, and Mr. Al. So this is how the sequence of this talk would be. We'll start with a question, a set of questions on time, related to time. So this is how we begin. And then the next thing would be Big Bang. So we look at Big Bang, and then we look at orbits, then we look at gravitation, water, gravitation and water. Does that make sense? I don't know yet. Let's find out. Direction, okay. Direction based on what? Entropy, light, orbital direction, harmony. Okay, so once we have the harmony thing, then yeah, maybe we'll have the God equation. So let's try to find this thing out. Now, on these slides or for this talk, I could add more things, but I could not remove anything that I have right now on the slides, because I thought this is how the sequence of this talk should be. There is no other way. All the things that I'm going to talk about today are critical to this topic, coming, trying to find the God equation thing. So a better way to understand today's stuff would be, if you see anything intriguing, take a brief note of that. We have papers here, we have pens here as well. So take this thing. Feel free to take pictures of the slides. Whatever intrigues you, do not wait for me to have detailed explanations, because I'll give you notion, I'll give you ideas. Also, I do not intend to talk a lot about the spiritual aspect, because that's my belief, and I would like you to have those things as food for thought. So explore on your own, agree, disagree. So we'll focus more on the bridging the gap thing between physics and mostly it's astrophysics or physics and spirituality or philosophy, okay? And feel free to ask questions. Feel free to interrupt in the middle. Do not wait for the end. Now, the big questions. What is time? Fundamental dimension of time. Wait a second. We have started with a question. What is time? But then why a question on time? Why not something else? Why not on food? Food is really important. Why not on water? Water is really important. Why not on oxygen? It's really important. So the first thing is that we are trying to find a holistic, universal kind of equation, right? A God equation. Theory of everything. But then why do we start with a question that is on time, not on oxygen or something else that is more critical? Do you have an answer? Do you want to say something on this? Yeah. Please use microphone so that your voice can go through.
It's not time. Would there be any process, for example, like, okay, oxygen, it should be some things moving inside it, right? Like any process happens through time, maybe time, that's why it comes first.
That's a good answer. Yes. Anything else that anybody else would like to add to this thing? Why time? Why not something else? Why did I not choose oxygen or food or water or something else or my life? Why not? Any answer? So the thing is that for how long one can survive without, let's say, food or water? Do you know the answer or any rough idea? 3 days without water? Okay. Yeah. It could be anything. I mean, I'm not looking for an exact answer, but the thing is that, what did he say? 3 days or something. Some days, right? What is day? It's time, right? And I'll die without oxygen within 10 minutes or so. 10 minutes, what is that? So it's time. This means that the most critical thing is time itself. It's not the oxygen. It's not something else. The most critical thing for existence is what? Existence itself. Being alive. I can ask a question or any question as long as I exist. If I do not exist, can I ask a question? I cannot. So existence itself is the most critical thing. And existence is defined by what? It's defined by time. Anything else is a subset of this thing. So the importance of oxygen, the importance of water, something else comes after. One can live without water oxygen, etc., this thing, that thing, without internet is a different question, comes after, right? So we know now why a question on time, right? There's no conflict. Where did everything begin? Okay, yeah, so if we talk about time, then of course we should talk about when did time start? So my time started when I got into this world, right? When I was born. So that was the start of my time. But you're trying to find the answer of time itself, time in general, not my time, time itself. So we have to go back to the beginning. Then the next thing is it a purpose? I think once we have the answer to God equation kind of thing, or once we're close to God equation, I think we'll have the answer. What is the purpose? Why time was created? And where did time begin? And yeah, there must be a purpose. If there is a beginning, there has to be an end. So my understanding is that if something is finite at one end, it has to be finite at the other end as well. If something is infinite at one end, has to be infinite at the other end as well. Generally, we say that, for example, natural numbers start from 1, 2, 3, 4, up to what? Up to infinite, right? So if something has a starting point, why that something has no ending point? It's not possible. We call it infinite because we cannot count it. That's why. So if something was there forever, has to be there forever, because they did not have a beginning, and hence they must not have an end. That's the concept. So let's try to find out, there must be a purpose. If there was a beginning, and we know through science that there's an end as well, let's try to find out the purpose as well. What's next? What is time? Isaac Newton, one of the most cherished scientists, said that time is absolute. So it's the same time for you, it's the same time for someone else, here, somewhere else, it's the exact same thing. But Albert Einstein said that no, time is relative. So a quick question, am I moving right now? How?
Can't be still like my laptop.
I can what? But relative to you in terms of motion, am I moving right now? Okay, I'm holding my breath as well. Am I moving now? No. So relative to you, I'm not moving. Relative to me, you're not moving. But relative to someone looking at us from the outside above the earth, we are all moving. The earth is moving at the speed of 1600 something kilometers per hour. So 1600 something kilometers per hour multiplied by how many hours do we have in a day? 24. So multiply by 24 and you'll get the, what's that? The diameter of the earth. So that's the speed right now. That's really fast, 1600, more than 1600 kilometers per hour. Right now, we're moving, everybody's moving. So if I'm moving like this now, whatever my speed is, that's plus 1600 relative to someone looking at us from the outside. But relative to you, my speed is just this speed, whatever this is, 1 kilometer per hour or whatever, right? Continued progress of existence. That's a good definition through dictionary. Why time? Do you have an answer? Quick answer. Why time? So that's a dictionary definition. Continued progress of existence. That's good. That's fine. But why time? Now we have got a dictionary definition of time, not physics definition of time. We'll try to find out. It's the biggest question because this is how we started our today's talk. So time itself is not an easy thing to answer. We have to do an entire lecture, maybe a micro course on this thing. But right now we just have a standalone lecture. So why time? Any quick answer? Why do we have time? We have got a dictionary definition of time, but then why time? Yep.
Time allows to measure.
Allows to measure. What?
To it sounds weird, but without it, we could.
But you're close to the answer. Yes, it's fine. Do you have a different answer? Or yeah, so you can see the answer here in the image. The direction thing, right? To avoid everything from happening at once. So something happens before something else. What is before? Yeah, before is time. What is after? After is time. What is now? Now is time. So past, present, future, all of these things are time, and we are bound by time. We need time, right? So this body that you can see right now is what is actually practically a bunch of days. With every passing day, a part of me vanishes. I'm gone with every passing day to the extent my time is driven, right? So every body is a bunch of days, or every body is a bunch of time. Label of moments. This thing happened before, after, etc. At this timestamp, at that timestamp, etc. Intervals between events. We've got some dictionary definition of time. We are heading towards the answer through physics. And as I said before, we have chapters kind of thing, the slide that I showed before, this thing. So we have got the definition of time. Now let's go back to the origin, right? How did time begin? It was a big bang, right? A big bang. Why big bang? Because everything was infinitely dense before. The universe that you can see now, can you get a scale of the universe, how big the universe is? Can you get an understanding of the universe, how big the universe is? We can see the largest object we can see now, the sun or something else. It's huge, really huge, right? But then at night we see stars, we see so many things. It's superly humongous, it's huge. When everything that we see now and everything that we see now is not everything, but whatever we can comprehend now was condensed, just like this. So, infinite density. It doesn't make sense, right? Infinite expansion makes sense. Something is expanded infinite. I don't know to what extent. That's infinite, yes, but then how come something is infinitely dense? Because it was infinitely expanded and expanding today. So when everything was so contracted, so conserved, it was infinitely dense. Hence, infinite energy. No law of physics were applicable at that time. And hence, because of immense energy, there was a blast kind of thing, Big Bang. So when Big Bang happened, time began. So that was the first thing. This is how time began. So now we've got an idea of, the question was time. We have got the dictionary definition as well. The next thing is, how did this thing begin? Big Bang. Yeah, Big Bang was a huge thing. And then expanding. Let's find out more things on this. Now, so this was the Big Bang thing. This dot here was the Big Bang thing, okay? And this is how, since Big Bang, the universe is expanding, just like this, okay? So expanding, it's not like this, it's expanding. So one thing is Big Bang, huge Big Bang, and then the second thing is expanding. So it's not like this, it's expanding, infinite. And we had something here, we had something there, so on, and then the first atoms were formed 380,000 years after Big Bang. First atoms. Keep in mind that atoms are among the smallest possible things that we know of. We have subatomic particles as well, we have quarks as well. So atoms are close to the smallest things that we know of. So the smallest things happened at that time. That created more things, bigger things, and hence we had 4 stars, galaxies, energy, everything. And then after almost 14 billion years, after 13.8, almost 14 billion years after the Big Bang, we have our universe. So staged creation of universe, staged. That's one thing. Second thing, expansion. So now keep in mind, there was a Big Bang and then ever expanding, ever expanding. Still today expanding, the universe is expanding. So when Big Bang happened, it was a blast kind of thing. So in all directions, things are expanding. This direction, this one, everywhere. 360 degrees. And if it's expanding, it means what? It's moving really fast, expanding, moving fast. So everything outside that we cannot comprehend is also moving. Continued expansion, right? There is no stoppage. It's not like something was created and then that's it. Now we have a defined, contained, finite universe. No, it's expanding every day. The distance is expanding. One more thing now. So we are done with time. We are done with Big Bang. And the next thing now is when Big Bang happened and we got the ever-expanding universe. The next thing was what? A really strange kind of thing. Because of the size of the objects, because of how they were thrown, they are in a constant orbital position, orbital movement. So since Big Bang, everything that we know of is in an orbital movement. That's a really critical thing to understand. Orbit. Orbit. Everything is orbiting something else. So one thing was, okay, conserved energy, infinite density, and then Big Bang. And then through Big Bang, everything is expanding constantly, infinitely. But then it's not just a speedy expansion, things thrown somewhere. No. There is an artistic science behind this thing. Because we have orbits, really intricate kind of orbits. But to what delicacy? Let's try to find out. That's our next chapter now, orbits. Do you have any questions? So now, another thing that we have to keep in mind is orbital survival. For existence, for sustainability, you have to have orbits. This is how everything is working right now. And we'll try to find this thing out. Each floating in its orbit. Sun was formed afterwards. So 14 billion years to the universe. And then 4.6 billion years ago, we had our sun. Okay? And about 4.54 billion years back, we had our Earth, close to the creation of sun. Recall the image that everything was in stages. You know, the Big Bang and you know those stages. The sun orbits the Milky Way at this speed. Wow, that's really fast. So everything is orbiting something. Everything in the universe is orbiting something. Orbit, keep in mind orbit. Big Bang, ever expanding, everything is orbiting something, and then it's also expanding as well. So if it's expanding and still orbiting, that's really difficult, right? High speed expansion. So high speed movement makes sense, but then high speed expansion and still orbiting, that's really difficult. It's not possible to have this kind of a setting or thing for something infinite and yet have orbits. So sun is orbiting the Milky Way. The Milky Way is orbiting something else. Our galaxy's name is Milky Way. Our neighboring galaxy's name is Andromeda. We cannot get there, so don't worry. We are orbiting what? The Earth is orbiting the sun, and we have other planets as well, right? So 4.6 billion years. Let's try to understand the orbit size as well, because we'll have a better context of how huge these orbits are. 4.6 billion years ago, the sun, and 230 million years to complete one trip. One trip around what? Everything is orbiting something. Sun is orbiting what? Milky Way. What is Milky Way? It's galaxy, our galaxy. So 4.6 billion divided by 230 million years equals to what? Just 20 orbits. As of now, as of today, just 20 orbits. That's too little, right? So this tells you, with this speed, if the sun as of now, since its inception, has just orbited 20 times, how many times have we orbited the Earth? Our one orbit is equal to what? 365 days, right? One orbit around the sun is 365 days, right? So sun's one orbit took this much time, and hence, as of now, after billions of years, sun has just orbited 20 times. So this tells you the magnitude. What's the biggest thing that we see in the universe? The biggest thing that we see is the sun itself, right? Sun is not necessarily the biggest thing, but the thing that we perceive to be the biggest. There are bigger things that we can see, but then they're far from us, so we perceive them as smaller things, right? Let's go ahead. Scientific timeline. Universe began 13.8 billion years ago. Earth formed 4.5 billion years ago. Let's divide this thing. What's the ratio? That's almost 3. So this tells us that the Earth is approximately 3 times younger than the universe, right? Based on scientific evidence, right? Let's look at this thing. Earth was created in 2 days, and universe was created in 6 days. Let's divide this thing 3 times, okay? So we have a correlation, and that's why I'm putting these things here. Take a picture, take a note. You want to explore more, food for thought. This is the bridging of science and spirituality/philosophy, to understand that, yes, we have a lot of connection there. So we do not need to ignore those things and just stick to science and say that, yeah, if we do not have evidence, then it's not true. Okay, so now we have got sun, we have got the Earth, our Earth, that's fine. We have got our solar system. How many planets? 8 planets. In the past, we treated Pluto as the 9th planet. Pluto behaved well, but then we found out that the behavior of Pluto is not so good. So we kicked Pluto out of the list of planets. Pluto is still part of our solar system, but not a planet anymore, I think since 2015 or something. I'll talk a bit more on this thing. But look at this thing. This is how our solar system is. We have planets, 8 planets, we have sun, everything is orbiting. Yes, everything is orbiting. The Mercury, Earth, Mars, Jupiter, etc. And how does this orbiting take place? In a disk kind of shape. So this is the sun, and then just like this, right? Sun and then something orbiting as a disk, right? Recall that through Big Bang, everything is expanding plus orbiting. So expanding plus orbiting. So it's really complicated. How? Just like this. This is how everything in the universe orbits. And this particular GIF is of the sun in our solar system, our planets. So it's moving in this direction, and it's orbiting. So moving and orbiting. And then you know the speed, 45,000 miles per hour for the sun, and similarly, you know, other planets. And we're just talking about our solar system. The universe is infinite, ever expanding. So many huge things out there. Now, since right now we're talking about the orbiting thing, keep in mind how complicated this is. So the math behind this would be really hugely complicated. A really small mistake could be drastic, or I should say would be drastic, right? A really small mistake, high speed, so many things going on, right? So now maybe take a note of this thing, take a picture, and we'll figure out more things on this. Pluto is an outlier. Because of an inconsistent orbit, Pluto is no more a planet. Now, the next thing to keep in mind is that, okay, if something has a weird orbit, that's not a good thing. High speed, so many things going on, right? I'll move fast now. Mercury and Venus have no moons, and Earth has one moon. And Saturn has 274 moons. We know one moon, our moon, right? So if something within our solar system has 274 moons, and our solar system is not the only thing that we have in the universe, how complicated this would be. So the pattern that these orbits make must be really complicated and may not make sense. But the reality is different. This is just one example of pattern of a couple of celestial objects orbiting something else, which is the sun here. How beautiful. So imagine the entire universe is made in this fashion. A scientist behind this thing, a scientist of everything, and the scientist is full of art, right? Big picture, planets orbit stars, moons circle planets, galaxies rotate clusters. Oh, atomic scale as well. Yeah, so largest thing versus the smallest thing. Everything orbits, electrons, particles. Even those quarks are also vibrating. We haven't observed them, but we have some theoretical knowledge of quarks. So subatomic entities here, these are subatomic particles. They also orbit, or in a kind of an orbital shape. It's not really an orbit, a circular orbit, but it's more of shaking thing. The bottom line is orbital is survival. That's the bottom line. Take a picture if you want. Universal principle of orbit creates stability. Nothing exists in isolation. Everything circles something else. So that's the bottom line here. Okay, we have got enough knowledge on orbits as well. The universe orbiting here, solar system, yes, atoms, everything, smallest thing, largest thing. Size of planets, small planets, large planet. So this is the largest planet in our solar system, 10 times larger than, 11 times larger than the Earth, and 10 times still smaller than the sun. And this is our sun. So we have neighboring stars, and they're so huge. That's not it, right? So complexity, right? Some of the text here, I think, or this text at the bottom might not be legible, but we'll try to understand something here. We looked at this thing here, small, large. These two things here on the right side, these two things, one above the other, they kind of mirror one another, right? For example, if you look at this one, this is Jupiter. If your weight is 100 pounds, on Earth, your weight on Jupiter would be 250, more than 250 pounds. Why? Because of the surface gravity Jupiter has. Why this huge surface gravity? Because of the size. Is it that simple now? Because the smallest one is Mercury. So let's see Mercury here. This is Mercury. Mercury makes sense, yeah. But then the planet size here, Mercury versus Mars. Let's look at Mars here. No, it doesn't make sense. This means that it's superly complicated. It depends on your orbital speed. It depends on the mass as well, and so many things. It's so intricate. So if your weight on Earth is 100 pounds, Or if you think you're overweight, if anybody thinks they're overweight, you're just on the wrong planet. That's it, nothing else. I think better option would be Mars. It sounds so good, right? So the purpose is to understand the complexity here, because we're heading towards what? We're heading towards finding the answer to time thing plus God equation. If an orbit fails something, a minute change in the speed, minute change in the orbital path would mean what? Destruction. So we saw orbit is critical, and anything that leaves the orbit, just like Pluto, is getting dangerous. So leaving orbit means that either you'll escape and get destroyed, or be hanging in the space without any gravity. What is gravity? I don't know. Let's find out. Or you'll get hit into something else and destroy yourself and somebody else. So that's the idea, right? That is the idea. And in the past, we have had these kind of things, dinosaur extinction, etc. In the future, something coming up, right? These things happen, asteroids, meteorites. And we have protectors as well. So Jupiter, as we have seen a couple of slides before, is the largest. And because of its gravity attraction, it keeps these kind of asteroids, the asteroid belt, intact and protects the Earth. You should be thankful to Jupiter. Thank you, Jupiter. So that's because of this thing. How amazing. So the size, the speed is keeping this thing intact. Now recall the expansion, fast movement, but still this thing is intact. Protection. How beautiful. And the same thing related to gravity. This is the equation for gravity. More gravity means faster drop-off ball. Okay? We have an understanding of this thing, gravity, 9.8 meters per second for the Earth. Some of the planets have different ones. And depending on the size plus the speed, both things. Fast, you would escape. Slow, collision with the next inner orbit. Collision, right? You have to be really perfect. So orbital velocity here. Perfect speed, perfect path. You cannot change anything. So that's the tricky thing. Water, we were talking about gravity. So we talked about orbit, we talked about gravity as well, and the variation in gravity. Now, why water all of a sudden? Our body is composed of water. We cannot live without water. No living being on Earth can be created or can survive without water. Do we all agree with this thing? Everybody, right? Okay. The Earth has 71% water. What's the relationship of this thing with gravity? We just talked about gravity. That's because of Moon's gravity. So Earth's gravity brings water down from what? From mountains. And rainwater comes down because of Earth's gravity. That's really nice. But then how does water move on the ground? We have seas, we have rivers. That's not because of Earth's gravity. So the purpose of Earth's gravity is just to bring water down from anything above, such as rainwater, such as water from a mountain. But then look at here. 71% water on Earth, just 2.5 to 3% is fresh water coming from mountains. Everything else is salt water, oceans. Everything else is oceans. The Earth cannot move that water. Do we need something for that? We need a satellite, a natural satellite for that. And that natural satellite is Moon. And Moon has a really beautiful fixed kind of accurate gravity designed for us. So now we have a better understanding of gravity is so intricate. We looked at some images before, how gravity differs. Can you quickly pick an outlier here? Something is different here. It shows the direction of orbit. So we know orbital movement is critical. We know gravitational force is also hand-picked kind of and has to be really extremely accurate. No derailing. This image shows direction. Is it an outlier? So Venus is the only planet in our solar system that orbits clockwise. Everything else orbit what? What's the direction? Counterclockwise. Keep in mind, okay? Yeah, so now our sun, Earth is orbiting the sun, creating what? Year. Earth is spinning on its own around its orbit, creating a day. And Moon is orbiting the Earth, creating what? Creating month. This is how. So are we getting close to the first question, time? Yeah, day is time, month is time, year is time. Yeah, that's really nice. That's why we had to understand the orbits and then gravitation. What about seasons? Yeah. So, the Earth is not at zero angle. There's an angle, right? A tilt. The tilt is 23.4 degrees. And the tilt is because of what? Because of the Moon. More water on Earth, Moon attracts. The distance between Earth and Moon and the gravitational pull of Moon creates that tilt. And that tilt creates seasons. This tilt creates seasons. We have time, we have seasons, more interest. Very interesting. We saw an image before that there's a direction. When it comes to time, there's a direction, right? There is a singularity, Big Bang happened, all of these things. Let's try to find why time has direction. Entropy, right? What is entropy? It's one of the most critical things in thermodynamics. You have a frozen ice, it has no or lowest entropy. When the ice melts, the temperature increases. That's high entropy. So anything that's from low entropy to high entropy creates a different form. This is a common thing in thermodynamics, and this is how the entire universe works. For example, the hot beverage would become cooler with time. Why? Because energy flows from high temperature to, right? So this is why we have a direction. Time has a direction, right? And you can explore more through Boltzmann's entropy equation. From order state to disorder and maximum disorder. So every living being has what? The smallest thing, or close to smallest, is what? The atoms or subatomic particles, electrons, protons, etc. They combine and they create what? They create molecules. Those molecules combine and create what? They create cells. Those cells create what? Let's say tissues or organs. So if the entropy of a subatomic particle is high, it would go towards the destruction. The orbital movement would cease, no more orbital movement. The end. So one subatomic particle stops moving. Similarly, another one, so on. And hence you have a cell that has died. And you have, similarly molecules and then cells and so on. And an organ has died now. The heart has stopped beating. Can you pause the heart? You cannot, not even for a second, right? So the moment those inner subatomic particles and cells and everything stops because of the highest entropy, it's the end. So everything heads towards the highest entropy. That's the message here. Chaos. Does anyone like chaos? Chaos is an English word that we use quite often, but it's used in a negative way, right? Chaos is never used in a positive way, and rightly so. But the thing is that we need to understand that chaos brings order. So when a fruit has over-ripened and fallen from a tree, it gets, let's say, buried in the soil. The seed has died. What happens next? The seed gives birth to another plant. So chaos brings order. Chaos brings what? Brings change. If there is lowest entropy, it means that life has ceased. Everything is so perfect. So the change brings life. And the change, low entropy to high entropy, brings what? Brings the direction. And that's why time has a direction. Now we understand what is time and why time has a direction. If you have a class, feel free to leave. I have to complete everything for the recording, and you can watch the recording as well. I'll share with them, and I'm happy to share the slides as well. So that's the message, chaos. It is perceived in a negative way, but it's not that negative. We have to deal with chaos, because chaos brings what? Chaos brings order. Life requires death. If there was no death, what is life then? Would we be able to comprehend life? So death is really important. Death brings life. Oh, let's talk about light. We haven't talked about light. What was the sequence? Time and Big Bang and orbit and gravitation, and then, the direction that we have seen, light. What's the most critical thing in our solar system? The sun, because we are orbiting the sun. Everything orbits something. So sun is all light. It's important to talk about light to get to God equation. What does the sun do? Temporal anchor, energy converter. We need sun for photosynthesis. We need sun for life. So keep in mind that life would cease to exist without light. And of course, the natural light, because we invented artificial light just a couple of 100 years ago. That's it. But before that, for billions of years, ever since sun was created, we have had sunlight, natural light. For what? For perception. Is reality real? It depends on the perception. Can you see me right now? Can you see me right now? Please look back. Yep. Can you still see me? Do I exist? Why and how? So I exist for you as long as you can perceive me. I do not exist for you if you do not perceive me. Same goes with someone looking at everything in this form. So time is for us. Time is not for the creator. So creator is looking at everything like this. There is no past for the creator. There's no future for the creator. We cannot go back in past because we have what? Entropy, a direction. There is no way. Time has a direction. The past is gone. But for someone else, a cosmic observer, they can see everything like this. This is the past. This is the future. I'm waiting for your future. Yeah. So that's the thing. It depends on the perception. If the creator stops perceiving me, would I exist for them? I would not. What is the speed of light? Yep. So the reason is that there was a big bang and all those kind of things. And we found out that there had to be a reason for time. So we are trying to find the answer to the question that we started this talk with, which was time. And we saw that we are bound by time, but the creator or whatsoever, let's call it nature. Nature created everything, right? So everybody believes in nature. If somebody does not believe in the creator, they still believe in nature. That yes, we do not understand how these things are happening in the universe. We do not know much about the universe. We just know a lot about the universe's behavior, which is a different thing. And that's why we are bound by time, and hence, somebody else is looking at everything. Yeah, Big Bang, and we talked about those orbital movements and everything. They're so intricate. It's not possible that they're having those kind of things on their own. If you throw some objects like this, they'll expand to an extent, and then they'll fall down. Even if they start swirling, they'll do it for a while, that's it. But then at that high speed, with these kind of details, it's not possible for those objects to keep on orbiting in this fashion. This is the speed of light. What is the speed of light of this light, artificial light? Do you know the speed of light of this one? LEDs or anything else? So nature created light. For us, through sun, for somebody else, through some other stars, the speed of light is fixed. Whatsoever you do, whatsoever kind of light you create, the speed of light remains the exact same, this one. Whatsoever you do, the speed of this light, that light, projector's light, this light is exactly the same as this one. Nature, the universe, gave light the speed. The light itself, photons, did not decide that we're gonna have this speed. Universe decided this thing. Why? Why? The answer is that it's for us. And we are tuned to this particular speed. We won't be able to live anything other than this speed of light. So you can take a picture of this one or watch this video later on, pause it there, and try to understand why. What if I have a different speed? Can I still live? The answer is kind of here. So the speed of light in vacuum is what I showed. In air is slightly less than that, slightly. In water, it's 0.75 or 75% of the speed of light in vacuum. If you go underwater, even with infinite oxygen, you cannot live there. We cannot, because we are designed for 299 or 300,000 kilometers per whatever the speed was. We have other creatures designed for different purposes. Another reason is humans are among the rarest living beings who can lay down on their back like this. Why? The modern civil engineering is not an old thing, maybe a few hundred, maybe a few thousand years back. That's it. But not billions of years back or millions of years back. Or human beings have been there for the last 300,000 years, right? So being able to lie on your back means that you should be able to look at the sky and the mesmerizing everything that the sky has. And you would be able to do that based on what? Based on light, because our vision depends on light. We cannot see anything without light, right? That's why. Cosmic time system, orbital framework, all these kind of things. Time, we've got the answer, but then what is this? Why are we in a grave loss? How does an analog clock work? It's clockwise, right? Right? It's clockwise. It has a direction. That's why. So we perceive time as going forward. Is it actually going forward? I had to import clocks for this talk. So is this the right time right now? This is the clockwise regular clock, analog clock, right? It's going in this direction, right? But the reality is that we are actually losing time, right? So that's a counterclockwise. I couldn't find it here, so I had to import this from somewhere else. It's in the opposite direction. Yeah, it is working. It's a real clock. It's just that it's opposite. You know the numbers here? It's 12. It's not 1, 2, 3. It's 12, 11, 10. So it's going in this direction, counterclockwise. Recall the orbits are also counterclockwise, right? Except Venus. So a few more minutes. The direction would change at some point. How is it possible? The Earth is orbiting counterclockwise, but then we have an outlier, Venus, which gives us an example. Maybe in the past something struck Venus so hard that the direction of Venus from counterclockwise became clockwise. Maybe, we don't know. But how was it so hard hit that it changed the direction but did not change the orbital path? Not possible, right? Maybe there's a message behind this thing. That at some point something will happen and the Earth is also gonna move in the opposite direction, but just for once, right? So why was time created? We have got a good answer now. We are heading towards the God equation. Yeah, chaotic reality versus structured reality. That's why. Yes, we have got seasons as well. Relativity in daily life. If I walk with this speed, time will be faster for me compared to cycling, slower for me, driving much slower, flying even more, even slower than the other ones. So what's the fastest thing that I know of today? What's the fastest? What? The light itself. 300,000 kilometers per hour. And that's why we use light for communication, fiber optics, right? That's why. That's the fastest thing. Whatsoever you do, there's nothing that we could create today, until today, that moves faster than light, not even light itself. There is no light that we could create that moves faster than the natural light or any other light. Not even light. So what does it mean? It partially answers your question as well. Somebody is light. Somebody is using light for communication. For light, the entire universe is just one point, nothing else. Light travels instantly. So from one point to another point, it takes nothing, no time, instant. For us, it takes time. For us, the fastest thing is, let's say, a spacecraft, spaceship, faster than this one, 1,600 kilometers or something, or double than this one, maybe 2,000. So human perspective, yeah, there is a direction, and for the creator or nature, everything is visible there. So the past is there, the present is also there, and the future is also there. For us, it's gone. For us, future is yet to come. Similar to entropy thing, if you can travel in the future, let's say you have a modern technology and you travel in the future, and you breathe just one molecule of oxygen, and then you come back into this time, the problem would be, there would be a huge disorder because you would have inhaled someone else's oxygen's molecule. So everything is so much in tandem. Just like the speeds that I showed of orbital movement and everything, the entropy, this is entropy, right? You're playing with entropy. So even if you can travel in the future, please do not breathe oxygen. Come back quickly, okay? How would you distribute time? Generally, it's morning, right? It's morning, so one division, and then you have a midday. So for a daytime, do we have different states? For example, the sun rises, state number 1. The sun reaches its peak, state number 2. Sun starts coming down, right? State number 3. Sun sets, state number 4. As soon as sun sets, is it too dark all of a sudden? It's not too dark, right? It gets darker with time, and after some time, it's pitch black or whatsoever, nighttime. So during daytime, we have a number of divisions, such as the morning, the midday after sun reaches its peak, and then we have evening, and then we have night, etc. How many divisions? 1, 2, 3, 4, 5. So let's look at the world map. My question is, can I divide my day equally wherever I am? The sun exposure everywhere on Earth is not the same, right? It's different. For example, the sunrise time, the daytime here is different compared to this, because the Earth has an axial tilt, and Earth is also moving. So it's not the same daytime everywhere. It's not the same nighttime everywhere, right? So I have to have a dynamic kind of time scale, the division of morning, midday, etc., evening, afternoon, etc., these kind of things. I've picked extremes here. A city from here, a city from here, a city from here, so north, south, etc. And then the equator. And for the equator, I've picked Kampala. These 5 cities. This blue line represents the nighttime. The golden kind of line represents the daytime. This is the morning or daybreak, midday, and sunset. So one division. So 1, 2, 3, and then as soon as it's the sunset, something here, and then you have the nighttime. I need sunlight for my everyday activities. Should I be using the sunlight to the best of my abilities? And then, I'm dependent on what? We saw that I'm dependent on sunlight for the sake of vision, for the sake of circadian cycle, biological cycle. We talk about work-life balance. Explore that. And you'll see that it depends on sunlight and, the nighttime. We can talk more on this thing, but some of the time, for today, this is how the division makes sense. Wake up at the time of sunrise or just before. Make use of the sunlight. Until midday, I should not be disturbed. Until sun reaches its peak, I should be getting the sunlight. I should be using the sunlight. We created light just a couple of 100 years back. Before that, we were completely dependent on the sunlight. So it makes sense to not get disturbed until this point, right? That's why the daily prayer, the second one, comes as soon as you have the midday thing, not before that. So you have 6 hours, 7 hours for concentrated work. And this is how the rest of the division is. So if something leaves the orbit, there is a destruction. We have seen this thing. What keeps orbit stable? Perfect balance, precise velocity, gravitational lock. So we have these things as conclusion. Can we use them for God equation? Orbiting directions and patterns. Direction also matters here. Direction. We have got this information now. It's a revisit of information, introducing the God equation now. Time component. Time is important. We have seen why time is important. Speed, we have seen why speed is important. Orbital parameters, right? Path created through balanced forces, the gravitation, all these kind of things, mass, it's critical. Existence function, which is the entropy thing. So combining these four things, we can come up with a universal balance equation, which is known as God equation. Quantum mystery, the subatomic things, the huge things, everything, speed, gravity, and this is your entropy. And that's the God equation that I have come up with as of now. It's unpublished, so I do not want this to be reused in any form. So that's the physics thing. The idea is that as long as you're orbiting until your time ends, you're good. You should be within the orbit. So the universe is orbiting like this. The small atoms as well. So universe and then small atoms, invisible things. Let's bridge the gap now. Moon orbits the Earth. Satellites, let's zoom in. Let's zoom in. Let's zoom in. Oh, wow. The origin thing that we saw, Big Bang thing, and the origin here. Let's relate these two things. Orbit. Orbit, yeah, makes sense. Wow. Everything orbits. So somebody sitting there is still in this direction, creates a virtual orbit. Right? A virtual orbit. What's the direction here? What's the direction? The orbital direction is what? Counterclockwise. So when you go there and you move counterclockwise, do you know the answer why? Because the Earth is moving counterclockwise. Everything is moving, right? So that's why. Now you know, if you did not know this before, now you know that the orbit here is symbolic, mimics the orbit everywhere else. But then the next thing is that why do I go there and then orbit in this direction, counterclockwise? And we know the answer as well, right? That is it for today. Thank you for being patient and thank you for being here.